Hello, I'm Ralph Gable of the Electronics for the Inquisitive Experimenter YouTube channel. In my last video, I provided a bunch of foundational information about things like, well, what is solder, and what are the requirements for a good solder joint, and what types of soldering irons are there, and how do they work. Today, I'm going to go over the tools of the trade, the must-have and the really nice-to-have stuff for soldering. I'm also going to give you a brief introduction to printed circuit board construction so that you will have a good idea of what's going on when you're soldering stuff onto a PC board. Feel free to leave a comment below if you have questions or comments. I make a concerted effort to respond to every single comment. If you find this video helpful, please click on the like and don't forget to subscribe. So let's dive into an introduction to the tools of the trade for soldering. Your basic soldering tools start with a good soldering iron station, or a soldering gun with a clean, well-tinned tip. Next, we have rosin core solder. Solder comes in all kinds of diameters, from the hair-thin stuff to the huge, massive stuff. The nice middle-of-the-road size like this 0.032 inch or 0.8 millimeter solder will cover most of your general electronics soldering needs. You'll also want a sponge for wiping your tip of the soldering iron on. This is an absolute must if you want to keep well-maintained soldering iron tip. Now, don't use a synthetic sponge. They melt. Now, to make it easy to wet my soldering iron sponge, I keep a bottle of water available, just an old bottle that I filled with water, available on the bench, so I don't have to go running to the sink every time I want to wet my sponge. Now let's turn our sights to a few hand tools. We need a good sharp pair of side or diagonal cutters. I do not recommend the large size used by electricians. In fact, I have come to use what is called flush cut side cutters. Now, don't skimp here. Mangling something you're trying to cut is not fun. Then take care of them. Use them only for cutting copper and component leads. Next, we also need some kind of needle-nosed or long-nosed pliers of the right size. Like the side cutters, we do not want the large industrial size pliers. There's a huge selection to choose from, so you'll likely need to shop around to find just the right pair for you and your soldering projects at a price you can afford, because these can get mighty pricey. Now, if you're taking parts off of a PC board, a solder sucker is really a great thing to use. Even if you're just cleaning up some messy soldering where way too much solder is put on, this is a great thing to have. And if you've never used one before, here is how to use one and how to maintain one. All right, so this is a solder sucker. You get it ready to do what you need to do by pushing the plunger in. That sets the trigger. This is the trigger button. You put it on the molten solder connection that you have, and you just push the little button here, and it sucks the solder up through here. They also have smaller ones like this one, which operate in essentially the same way. You have a plunger and a trigger. But you need to do maintenance on these things because solder gets all up inside of the barrel, and plus they have a seal inside of here that allows that plunger to seal and suck well. So first of all, you can see you take it apart by doing this, and you can see that this has been well used. It's all full of thickness. So we're just going to take a paper towel to begin with, and we're going to wipe off the whole mess here. And there's a little O-ring inside of here. You can see the little O-ring right here. And so all I'm going to do is take a little bit of this silicone grease, a little on my finger here, and I'm going to make sure that this plunger has a nice coating of silicone grease on it. I then take this part and I make sure it is completely empty and put it back together again. Now, it is all ready to go. This one's a little bit different. You empty the shards of solder by unscrewing the end here. And you can see in the end, and that's all you generally have to do on a daily basis. There's a little seal here. You could put just a little bit of silicone grease on that seal to make sure that it stays nice and sealed. You don't want any air leakage at all, because that reduces the amount of suck that the sucker has. And then we screw this back into place. And once that's back into place, we can wipe off the excess silicone grease, because we really don't want that on our hands. And you say, well, what about the plunger part? Well, there's a screw on the other side here. We take this screw out, and then the entire plunger assembly will come out with some help. And you can see again, it has the seals and everything here. We want to kind of wipe that off again with our paper towel. And then, like the other one, we want to take a little bit of our silicone grease and make sure that this is well lubricated. If it's not well lubricated, then it won't slide well in the barrel, and then you don't get the sudden suction that you'd like to have in your solder sucker. Then when you put it back together again, you kind of come in at an angle from the end, and you notice how that just kind of slides right in. And then you put it in until the screw hole on our trigger assembly sticks through here. And then we search for the screw. Here we go. We put our screw back in. Be sure to secure that real well. Not too tight. And then we test fire it. See, now you know there's a good seal on there, because watch, if I have it open, it just comes up. If I have it, my finger over the end of it, and I hit the button, so that's working beautifully. There are also the supplies we should have on hand, like solder wick. Now, solder wick is a great tool for removing parts, especially if you're going to be working with surface mount parts, but that's another video. It comes in various sizes. It's like what you might have if you strip the braided shield off of some coaxial cable and then impregnated it with flux. But like anything else, the right size for the job. For those times when we need a little extra chemical help to make a good solder joint, some electronic soldering paste is a great thing to have. I'll often dip my wire in this before attempting to tin it. This makes for a fast and furious tinning process and avoids unnecessary insulation melting. If you're doing PC board work, I also highly recommend having a flux pen in your tool belt, This is really great for adding a bit of additional flux to the PC board pads to make quick work of the soldering process. After you're all done soldering on whatever it is that you're soldering, you need to remove the residual flux from the connection. Now, there is official flux remover sprays and the like, but this can get a little bit pricey. Plain old 99% isopropyl alcohol is the inexpensive way to accomplish this. Go to your local pharmacy and buy a bottle of 99% isopropyl alcohol. Pay attention to the label. Some of the isopropyl alcohol is 50%, some 70%, and you don't want all that water on there. You want to look for the 99% isopropyl alcohol. Now, to go along with the isopropyl alcohol, you'll also want to buy a bunch of acid brushes. Now, the bristles of acid brushes are generally way too long and floppy. So I cut the bristles about 3/8 of an inch or 9.5 millimeters to make them stiff enough for the cleaning job with the alcohol. While you could use any particular kind of tape that you like, I like to use the blue painter's tape to secure things in place while I solder them. The reason why I like this stuff is that it sticks well enough, but comes off easy and leaves no residue behind. And then there are the tools that are not required, but are a real help. We've often ended up wishing we had an extra set of hands as we chase things around to solder them. Even if we have them taped down, it still is not very convenient. Now, there are 3 tools which are a real blessing in this count. One of them are forceps. Many years ago, a fellow gave me a bag of hemostatic locking forceps. I have somewhat of a variety of sizes and shapes. I have both straight and curved forceps, and the ever cool and useful back hawse towel forceps. These are really cool, and I use these things for 3 basic purposes: as mini micro needle nose pliers for really small places, or holding on to stuff, or as a heat sink to prevent stuff downstream from getting too hot while I solder things. Then there's what I call the second hand stand. It looks like some little weird thing with alligator clips on it. It is very, very handy to have that on the bench. I have found this little device way awesome to hold on to things while I solder. Like here, this 9-pin D-sub connector while I'm soldering a wire into one of the pins. Now I have one hand for the soldering iron, one hand for the solder, and nothing's moving on me. Or like when I'm soldering 2 wires together, this butt splice. Now there are much fancier ones like this one, but this little simple one is quite sufficient for most people. I used to have to tape PC boards down to the bench using my handy dandy blue painter's tape. Unfortunately, that means that you really can't get at the bottom or the other side of the board while you're working on the top side of the board. It kind of works, but it really doesn't work very well when you're working on PC boards. So, as an option to taping the PC board down to the bench, you get this PCB vise. A PCB vise like this one is just way awesome. It's heavy, it's got plenty of places to stick parts and things. You can clamp your PC board in place, and it allows you to get at both sides of the board at the same time and flip it over quickly and easily at will. Now, I don't know about you, but as I get older, it gets a little bit harder to see things. Even when I was younger, some of the things I was soldering iron, man, trying to see exactly what I was doing was pretty tough. So having an illuminated magnifier like this one helps an awful lot. Now, This is certainly not an exhaustive tour of the tools that you might want to use in our soldering, but it will certainly get us started down the right path. I want to spend a few moments describing PC board construction. Knowing how these things are created will help a lot in knowing how to solder on them. Now, I'm not going to spend a lot of time on this, just enough so that you know what might be going on. Now, PC boards are laid out in 3 dimensions. The length and width, well, that's easy, we can see that. But the 3rd dimension is the layer. The layer count usually refers to how many layers of copper are available for routing signals. The simplest board have a single layer, usually on the bottom of the board. One of the biggest challenges to designing a PC board is often routing space to run the signal, ground, and power around the board. The arrangement of the components helps, but sometimes you just have no way to get one trace around another to get where you need to go without having to take the scenic route around the board. In years past, they would use wire jumpers to accomplish this task. In order to increase the space they have for routing, they add layers to the board. This way they can drop down from layer 1 to layer 2 and run the signal under the other trace, and then back up to layer 1 to finish the run to the final destination. They use what are called vias to run signals vertically through the board to connect to the copper traces or planes on other layers of the board. Vias are plated through holes running vertically through the board. Boards can have as many as 10 layers and more. It kind of looks like this. We have copper on the top, followed by the fiberglass core, followed by another layer of copper. The fiberglass core can be very, very thin. This forms a 2-layer board. They take several of these and sandwich them together with the insulating, what's called the pre-preg material between the boards. The copper on the board is used for conducting power and signals, but it's also used as a heat sink for certain components. This copper can vary in its thickness depending upon how much current they plan on using on that layer or how much heat they're going to expect to have to spread. Being able to heat the point to be soldered is an important part of the soldering process. As such, there are certain thermal considerations we have to address when soldering on PC boards. If the pad to be soldered is connected to a signal trace or a pin or a signal path, there is likely not going to be a high thermal demand on your soldering tool. Then there are the ground or power planes, which are the large expanses of copper poured over the board to provide low impedance path for power and ground. There are 2 basic methods of connecting a PC board pad to one of these planes. The first are thermal spokes. Now, if you look really closely at the pad, you'll see up to 4 short spokes between the pad and the plane. These provide thermal relief for soldering. We have short, low impedance runs for the electrical side of things, and some, quote, thermal distance, so the plane doesn't suck all of the heat out of your soldering tool. And then there are the direct connect. With direct connect, the pad just looks like a hole in the plane. These are the real bear to solder because the plane sinks heat like crazy from your soldering tool. If the pad is connected to a ground or power plane, this may represent a fairly heavy demand on the capabilities of your soldering tool, even if it has thermal spokes. The connections to these big thermal sinks may reside inside the board on buried layers of the board. In this case, your heat travels through the associated via to the plane. You can expect this sort of soldering challenge with VCC and ground pins of devices, bypass capacitors, pull-up or pull-down resistors. So there you have the tools of the trade and a brief introduction to PC board construction. In the next video, I will be actually performing some soldering demonstrations so you can see how it's done. If you found this video helpful, please click on the like and subscribe to the channel. Thank you so much for watching. Until next time, toodaloots.